So today is the last day of Unit 3. Woohoo! We are going to answer the question, how do we model real-world situations by using systems of inequalities? So we went over how to graph systems of inequalities yesterday, but now we're going to do it with real-world situations, which we all know just means word problems, our favorite. All right. So we're going to be looking for our keywords, and, if we get anything along the way that we don't need, cross it out. A high school drama club is putting on their annual theater production. Yay, good for them. Okay, that has zero value to us. There is a maximum, that's a nice word, maximum of 800 tickets for the show. Okay, so that means I cannot hand out any more than 800 tickets. So I'm going to say less than or equal to 800. Okay, the cost of the tickets on the day before is $6. And so if you get them before the day of the show, that's going to be $6. If you buy the day of the show, it's going to be $9. So here's going to be our two variables. So I'll call this one X and this one Y. So when you guys are doing this, you have to make sure that you make a let statement. Okay, so we're going to say let X equal tickets bought before show, and then Y is going to be tickets bought day of. Okay, so let's read the rest of this. So the club needs to make at least $5,000 worth on the tickets. Okay, at least. So we can make more. So greater than or equal to 5,000. Okay, remember we are going to have two inequalities because it is a system. Okay, so the first one I'm going to do is the nice easy one. So X plus Y is less than or equal to 800. Okay, we cannot go over that many tickets. And the next part is our profit, right? How much we make. So 6X plus 9Y, okay, those, I literally just took those from how much a ticket costs, okay? So each ticket, whenever you see that word, or if you can say that word and it makes sense, each ticket costs $6. That screams multiplication, okay? And we want to make more than or equal to, since it says at least, $5,000. Alright, so if this was a 2-point question on a regent, that would probably get you 1 point. Alright, it's a lot of work. Okay, so no silly mistakes. There's no room for it. Alright? Okay. So then we're going to answer the rest of the question. So the club sells 440 tickets before the day of the show. Is it possible to sell enough additional tickets on the day of the show to at least meet the expenses? Okay. So basically what we're going to do, so again, same equations that I had. Leave all of that actually. Okay, so basically what you're going to do is you're going to substitute in the 440, and this is just like how we solved our equations, right? So when we solved the system of equations, we substituted one in. Okay, so if I substitute the x in, I can get the y. And then I'm going to substitute the x and the y in to see if it works. Okay, so when you substitute them both in, and remember we're subbing them both into the money equation because that's what we're looking for. They're asking us about the money. So will we meet the expenses? Okay, so you see that it's true, right? Now the last thing, so it does say justify, but it asks you a question. So here's where I love and hate the regents. So it's a great question. I know that all of you would be able to do this. If it asks you a question in a word problem, please just write a sentence. I know I told you that justify means with math and explain means with words, but sometimes you just have to think about it, all right? It's asking you a question. Is it possible? So at some point you have to say yes or no, okay? And then explain why. If you did say yes, it is possible to sell enough additional tickets on the day of the show and showed all of this work, you probably don't need that second sentence. But again, if you're stating factual stuff, then just let the words flow. All right. All right, Edith. Nice name. Edith babysits for X hours a week. After school, at a job that pays $4. Sorry, did not notice it wasn't in the vision. $4 an hour. She accepted a job that pays $8 an hour as a library assistant, working Y hours. So she still has both of her jobs. She's able to work no more than 15 hours a week due to school commitments. Edith wants to earn at least $80 a week working a combination of both jobs. So we need to write the system and then we are going to graph it. So I do apologize, that is a tiny graph, but you know I will give you a bigger one. Okay. All right. So again, you want to break this down, okay? So when you break this down, when I say to break it down, what I mean is you have to make you got to do your underlines, okay? So it's important that you know babysitting is X, all right? The library assistant is Y. That's important when we talk about the money. Remember, at least is going to mean greater than or equal to. No more than means that we cannot go over 15 hours. So you're going to, first you're going to write your systems of inequalities and then you're going to graph them. Remember, we're graphing inequalities. So where they intersect each other, which if you look, that would be, do a highlighter, that would be right in here, okay, right in this area. All right, and this represents numbers. Okay, so hours babysitting is going to be X, because I said so, and hours at the library are going to be Y. Okay, so I'm just going to, basically what I want to do is I want to pick a coordinate. I want to pick a coordinate that is in the solution. So determine and state one combination that will allow Edith to earn at least $80 per week while working no more than 18 hours. So if that were true, any of these solutions would be an answer, and I just picked 210. So again, you could have a different answer if you were answering this yourself, because there's infinitely many solutions. All right, next one. An online electronics store must sell at least $2,500 worth of printers and computers per day. Each printer costs $50 and each computer costs $500. The store can ship a maximum of $15 per day. So again, we want to graph the system of inequalities that models these constraints. So these constraints, I don't know if you've ever seen that word, but a constraint is basically just, I want to write my systems of inequality that represent the word problem. Okay, your constraints are, you know, what are going to be your one inequality and what's going to be your other inequality, and then we want to know where they intersect. That is our answer. That is our solution. Okay, so again, X is the number of printers because they didn't tell me. Okay, so with the last questions, we didn't have to do the let statement because it told us what was X and what was Y. This one does not, so please make sure that you write your let statement. It's very important. So I cannot more than 15 items per day, so it's going to be less than or equal to, so x plus y less than or equal to 15. And then I want to at least sell $2,500. So I'm going to do a greater than or equal to 2,500, and I'm going to multiply the x and the y by how much one of them costs. So then to graph them, remember we always have to put them in y equals mx plus b. I drew a nice S over top of the solution set. So anything in that whole entire area, okay, right in here. And again, you're not going to pick 1.5. Well, that's not in the solution set, but you're not going to pick, 5.5 printers, right? You're going to pick whole numbers. So anything in that whole area. So what I said is they can sell 2 printers and 6 computers. And then I basically just restated the question. Okay, so the 0.26 is a solution to both inequalities. So that is a great explanation. Remember, explanation means with words. All right, 2 more, I think. All right, cherries cost $4 per pound. Grapes cost $3 per pound. You can spend no more than. Okay, so that's going to be less than or equal to $30 on fruit, and you need at least, let's get that one out, at least, so greater than or equal to 4 pounds in all. So that right there is showing you your 2 separate equations. Okay, one is talking about money, and the other one is talking about pounds. All right, so pay attention to those things. So if at this point it's been hard for you to figure out how you're going to write your 2 separate equations, that's the thing to look at. One thing always talks about money. In the first problem, we were talking about tickets. All right? So one of them, they were talking about the price of the tickets. The other one, they were talking about the quantity of the tickets. Those would be the 2 separate inequalities. This one, we're talking about money for one, and then we're talking about pounds for the other one. All right? Again, these are all going to be upwards of 4 points or possibly even 6-point questions on your Regent. So it's really important that you guys focus. Please ask me questions if you do not understand, because you will get questions like this. Very important. So again, they didn't label our x and y, so you have to do that. Again, this is called a let statement. Once I get my inequalities, so I know x plus y is greater than or equal to 4. That's because I want at least 4 pounds. And then I can only spend $30. So 4 times x, that would be the cost for the cherries. 3 times y is the cost of the grapes. I solved for y for both, found my m and my b, and then I plotted them. And then, of course, when they ask you that second part, so here's the other thing I want to point out. Determine, okay, so think and state. If it says state, they're looking for this, and they're looking for this. All right, so please make sure you answer the question. So 2 pounds of cherries and 3 pounds of grapes. All right, that would be one possible solution. And again, anything in this little area right here would be a solution. All right, last one. Oh, this makes me miss my little baby. We'll call her Junie, because that's my dog's name. All right, a dog walker earns $15 per hour. He also earns $10 per hour for babysitting. He wants to earn at least $300 next week, but can work no more than 40 hours. So we're going to do less than or equal to, and at least can be greater than or equal to. Okay, so on the set of axes below, graph a system of inequalities, modeling how many hours he can work at each job. Simple enough? Okay. So again, it didn't give us our x and our y, so make sure you do that let statement. So x is going to be for dog walking, y is going to be for babysitting. The reason why it's important that you guys do your let statement is to, number one, keep yourself organized, but also if you said x was babysitting and y was dog walking, that's okay, as long as your graph looks that way, your equations, your inequalities are the same, and then you answer the question correctly. Okay, so that's why it's really important that you actually use your, you got to use your solution. I haven't said this yet, but labeling your axes, that's smart as well. And then again, don't forget to answer that last question. They're always going to ask you for a solution. What was the solution? So remember, that is going to be where those cross hatches are. Okay, or where I just drew the S. Okay, so he can walk the dog for 10 hours and babysit for 20 hours. So that's well below the 40 hours that we can work, but we are making more than or equal to $300. Right, and that's the end of Unit 3.